Hey everyone, thanks for your time as always. Given all the political twists and turns this year covering NASA's exploration programs, usually called Artemis, I was able to get a detailed update on the Gateway's power and propulsion element directly from Lanteris Space Systems, the prime contractor. There are a lot of angles for each of the programs in the Exploration Directorate, and PPE is only one element of Gateway, but you have to start somewhere, and under the circumstances, I had to start over with the basics. Lanteris is building the PPE for NASA, and the first thing to find out was the current status of assembly and test. The here and now. Then going from where we are to where we are going, what's next? And then looking farther down the road a few steps. NASA hasn't been specific about the launch date of the co-manifested vehicle for Gateway that includes PPE, other than to say it is no earlier than 2027. There is a lot more I'm still wondering about the program, like the launch date and the other elements, but it was good to get some needed detail about what's going on with PPE, and I'll start with a little historical context before getting into the interview. At the end of October, I got the chance to speak with Chris Coker, who, in his role as Vice President of Civil Space Programs and Robotics, leads the Power and Propulsion Element program at Lanteris Space Systems. NASA awarded Lanteris Space Systems, previously Maxar Space Systems, the contract for the PPE back in May 2019 at the front of the Artemis rebranding and reorganization of NASA's Beyond Earth exploration programs. The competition and the award was for a standalone spacecraft that was and is the foundational element of the Gateway. The element uses solar electric propulsion that allows for major translational maneuvers in cislunar space. The PPE concept evolved from studies in the last decade about an asteroid redirect mission where an uncrewed electric-powered spacecraft would capture a near-Earth asteroid. The power and propulsion bus concept for a deep space gateway was further developed by NASA beginning in 2017. At the time of the award, NASA's top priority had just been changed to landing the next astronauts on the Moon by the end of 2024. As a part of that race against the calendar, the initial Gateway elements became something like a base camp for the Orion spacecraft and where it would meet a to-be-determined lunar lander. An initial minimal habitation element, which was planned as the second element to be independently launched, was considered necessary for Artemis 3 for several months until the end of 2019. The new head of the Exploration Directorate, as it was organized back then, Doug Lavero, was given the directive to focus on that top priority, which had been phrased by then Vice President Mike Pence as landing on the Moon by the end of 2024 using all means necessary. And at that point, the design of the PPE began changing. Lavero decided to cut the Gateway out of the Artemis 3 mission, but also made another big change. He decided to integrate the PPE and the minimal HAB element, now called the Habitation and Logistics Outpost or HALO, on the ground and launch them together in the name of minimizing overall mission risk. However, that also meant that the PPE was now going to have to serve as not only a tug for itself from Earth orbit to the Moon, but also for HALO. Originally, a Falcon Heavy would launch PPE into a high Earth orbit, and the spacecraft would transit from there to the Gateway orbit, something in a class of cislunar orbits called a near-rectilinear halo orbit, or NRHO. But the change doubled the mass that Falcon Heavy would have to launch, and that PPE would then have to transfer from the Earth to the Moon. The PPE and HALO together are also called the Gateway Co-Manifested Vehicle, or CMV, and together are expected to weigh 18 metric tons, which means that PPE will be starting the spiral from a lower Earth orbit. Going back to the last decade, NASA had looked at PPE concepts that would perform more of a demonstration electric propulsion maneuver, such as this one from a hypothetical SLS Block 1B launch, that would see the hypothetical spacecraft fly by the Moon and make a long loop away for a 75-day transit, so to speak, into an NRHO. SLS Block 1B is still in development, and currently there is no U.S. launch vehicle with the performance or the availability to send PPE or the co-manifested vehicle on a translunar flyby trajectory. An expendable Falcon Heavy is far and away the highest performing launch vehicle that is currently available, and it was selected to launch the CMV. It will release the spacecraft in an Earth orbit of about 34,000 kilometers by 200. From there, the PPE will need something around a full year to make the transfer to the Gateway's specific cislunar halo orbit, firing its electric propulsion systems much of that time to spiral out to the moon. Recently, Lanteris provided the update that the spacecraft had completed its initial power-up milestone and provided an image of the PPE. Initial power-up is a major milestone in assembly and test, and at the top of the interview, Mr. Coker talked about the current status of the build. I really appreciate that you guys are willing to give me a little bit of time to ask about this. And so, for the power and propulsion element, I mean, I think sort of a starting question is really just current status of assembly, integration, and test, and again, kind of putting that work into sort of an overall context of where you are ahead of launch and so on.
Sure, and Phil, I want to say thank you for giving Gateway some attention and focusing on it, and so definitely happy to meet with you today and talk about it. With the power and propulsion element, we are in what we call our spacecraft testing phase. So I think you've seen one of the pictures that we released of the spacecraft. So it's integrated. If you go out into a factory, instead of seeing pieces of spacecraft, you see what looks like an assembled spacecraft. So that was a critical phase. In September, we accomplished what we call our spacecraft power-up phase. And that's a major milestone because that enables us to start doing spacecraft level testing. And that's the phase that we're at the moment. We are pushing forward to start our environmental testing phase in the early 2026 timeframe, which is aligned with the schedule that supports NASA's needs as well. So we're on a good pace. We're on track, and the power up milestone that we talked about that we achieved in September was a big step to enabling that. On the thruster side, we have two of the 12 kilowatt thrusters from NASA. The third one is on track, and the delivery of that is in line with our needs from an integration perspective as well. We have four of the BUSIC thrusters that we are integrating onto their subassemblies, and then those subassemblies will go on to the spacecraft prior to the environmental testing phase. So it's really exciting to see all the pieces come together, and all those pieces come together in our factory. And the photo that we released highlighting the power-up event is a good visual piece of evidence of it all coming together. And as we have started testing and getting performance data, we have a lot of good momentum right now, and it's exciting to see.
I actually did want to ask a question or two about the picture. So I hope it's something that you either have or you can visualize or have handy. But the spacecraft is in a vertical orientation, and I mean, my guess was that it's inverted, but is that correct? Is it?
Yeah.
Okay. So because I can see some of I can see RCS thrusters, but I know that they're on both ends of the bus. Let's see, and then just again, kind of a ballpark. Approximately when was that taken? Was it taken around the power-up milestone?
Yes. Shortly, like within a couple weeks before that, because the predecessor milestone to power up was putting the equipment panels onto the equipment panels, or the panels that have the mirrors on them, the big panels that I think that the photograph had at the front face. So integrating those, there are two of those. Integrating those onto the spacecraft structure was the milestone, and then you go to power up. Can you power up the spacecraft? Can you do things with it? And then after that milestone, we start our testing. So those 1, 2, 3 major events are all within 6 weeks of each other.
Okay, and then just out of curiosity, and maybe these are on different something that'll be installed later, but Are those the faces with the faces you're talking about? Do those incorporate the radiators, or are the radiators going to be installed later?
Those are the radiators.
Okay. Let's see. Okay, and so okay, you talked about the SEP thrusters, and one of the other things that we saw a couple of months back was the red wire. They I guess they had I don't know if they had media out there, but they did an event when they did a testing of one of. I think it was one. I don't know if it was both of the rollout solar arrays, but I think they'd mentioned that they were targeting delivery in this quarter or thereabouts. What's the status of that?
Yeah, the target delivery is by the end of this year.
Okay.
End of this quarter. We're in October, so we're in the fourth quarter. So yes, that is correct.
As Mr. Coker said, the spacecraft is inverted in this image, so the aft deck where the solar electric propulsion thrusters will be installed is on top from this point of view. There are 7 electric thrusters, a set of 3 12-kilowatt advanced electric propulsion system thrusters from L3 Harris, and a set of 4 6-kilowatt BHT 6000 thrusters from Busek. And as he noted, all of them have been delivered with the exception of the final L3 Harris AEPS unit, which is in final acceptance test at NASA's Glenn Research Center, or was in final acceptance test, and then would be delivered from there. That's one of those updates we'll ask NASA for now that government funding is restored. As this graphic depicts, all but one of those thrusters are steerable, with the Busek 6-kilowatt thrusters being mounted to gimbal mechanisms. Those are the subassemblies that Mr. Coker was referring to. The electric propulsion system uses xenon as a propellant, and the PPE also has a more conventional chemical propulsion system that uses hypergolic bipropellants. We can see many of the reaction control system thrusters already installed around the perimeter of the main spacecraft bus. Lanteris provided a couple more pictures of the spacecraft during assembly this year. Those RCS thrusters stand out in this one before the equipment panels were installed. This shot is obviously around the same time as the initial one, after the panels were installed. It provides a little different view of the spacecraft oriented horizontally. The hypergolic RCS system can be used for translational maneuvers, but that's the primary responsibility of the electric propulsion system. The RCS would be used primarily for attitude control. However, you'll hear this question go by a little later. The PPE also has reaction wheels for non-propulsive attitude control. We can see one of the locations where the base of one of the 2 large red wire rollout solar arrays will be attached to the spacecraft. They provide the power for the SEP system and for other spacecraft systems on the PPE, and the eventually mated Habitation and Logistics Outpost module. Earlier this year, Redwire provided video of a deployment test of one of the arrays, and as noted, the forecast is for those to be delivered to Lanteris by the end of this year. I then asked Mr. Coker about what was next in terms of testing the spacecraft now that it can be powered up. What are some of the other subsystems that you're testing on the spacecraft that's already integrated? You talked about environmental testing. Is any of that done in like an altitude chamber or a vacuum chamber?
It is. Environmental testing consists of testing in a thermal chamber in vacuum. And then environmental testing also consists of dynamic loads. Shake and bake, as we like to often say in the industry. And so the thermal vacuum testing will be the bake part, and then we will shake it to simulate the launch environment. So when I say environmental testing, I'm talking about specifically those two areas, as well as acoustics testing. But in order to start that, we need to confirm that the spacecraft will operate in the ambient environment as designed, and that is the phase that we started in October, is doing the ambient testing to show yes, it works as designed at ambient, and then the environmental testing confirms that it works in the different environments that it will see from launch through the orbit raising to the end of the mission.
Okay, and then again, just trying to get a sense of the sort of the road ahead to, and thinking down the road to when the spacecraft is ready to go to launch site. But you have you have the propulsion systems, and you have the solar arrays. Where how do those get installed, and then would you be doing environmental testing without them first, and then after they're installed, or how exactly would that sequence flow?
Yes, some of the thrusters will go on for environmental testing. Certainly, we don't fire the thrusters in the environmental chamber. That's not that firing the thrusters, the testing and verification of that happens with the vendor. What we confirm in our environmental testing is, do commands go to the thrusters? Do commands go to the solar arrays in the way that they are designed to do so at the different environments? So, but the thrusters and the solar arrays will be added and installed in advance of our dynamics testing. Right? You want the spacecraft fully assembled when you shake it to demonstrate that it will withstand the launch loads, the physical launch loads. But the thrusters and the arrays aren't needed for the thermal vacuum testing, for example. If we have them and we can do the testing with those on, we certainly want to put them on as sooner rather than later. But that's more of a manufacturing convenience thing than it would be needing to do it. What's critical for the thruster assemblies and the solar arrays is to be installed for the environmental tests, where we shake it to simulate launch environment.
Do you have the test chambers there on site, or are they nearby or regional, or do you have to ship it to another place to do those?
The test facilities are on site here in our facility in California.
Okay. Okay. And so I guess maybe at a sort of at a high level, then you're talking about thermal vacuum testing, environmental testing. Are there other, I guess, what would be the other sort of major milestones from here to when the spacecraft is essentially ready to be delivered?
So after environmental testing, we will do what we call our final testing phase. And a big part of that consists of deployment tests. Anything that deploys, the thrusters, the arrays, we will show that we will deploy to them. And that demonstrates that after all the environmental testing, the deployable will deploy as expected. So that's a big part of what we call our final testing, final assembly phase. So that happens after the environmental testing, right? So right now we're in does the spacecraft work at ambient? We confirmed that. The phase after that is environmental testing. Does the spacecraft work as designed in all the different environments? And then the final phase is do the deployables deploy as designed after exposure to all the environments. So those are, if you think about manufacturing and test flow through our factory, those are three buckets to think about it. And it's important to note that it's the same manufacturing and testing approach, the same flow as we've used for our commercial communication spacecraft for decades. And that is important to NASA because one of the big reasons that they partner with us on the PPE is because our Lanteris 1300 spacecraft has decades of flight heritage, and there's reliability benefits that come with that. So NASA has been very careful not to micromanage us, not tell us how to build the spacecraft, not tell us how to test the spacecraft, to let us do it in the flow and in the order that corresponds with how we've done it on commercial programs, so that NASA gets the same reliability that they would get, that our commercial programs would get. Now, it's important to note that this is a space station. Humans are going to be on board the Gateway. Not in instances where NASA human rating standards may be different than our commercial practices. What they've done is taken an approach of, are there additional inspections that we can do? Is there additional testing we can do, or additional data that we can give NASA so that NASA can confirm, yes, we are in compliance with those safety practices. And that's worked out very well because it allows us to build the spacecraft as we have our commercial spacecraft. It allows us to keep the same schedule or operating rhythm, if you will, building the spacecraft, but it gives NASA the data they need in order to have the confidence that this spacecraft will operate on a human-rated mission as designed. So that's been very important to us. NASA could have micromanaged us on this. They have not, and they've gone to great lengths not to do that because they realize there are reliability benefits to how we do things, and certainly there are schedule integrity benefits as well.
I also asked about how the two elements of the Gateway co-manifested vehicle, the PPE and the HALO, would be integrated. Following the redesign to dock them on the ground before launch, rather than autonomously in the Gateway orbit, they are physically connected by an interelement adapter. How the PPE and the HALO are integrated. I know that there's also this interelement adapter, which I assume to be more of a structural element. But what are some of the other connections that you have to make between the two spacecraft?
Yeah, there are the refueling connections. There's also electrical connections as well, and the adapter enables that. And we've done a fit check of the adapter. It's been several months since we've done that to confirm that the adapter integrates to PPE as designed. HALO did a similar one for their spacecraft as well with the adapter. So we have confirmed that we can attach to the HALO through that adapter in all those interfaces. So I would say that was a key risk reduction step in ensuring all the different interfaces can connect the way they're designed.
The Lanteris 1300 he referred to is the Lanteris 1300 series spacecraft bus that PPE is based on. Multiple NASA spacecraft were built around its long heritage. To summarize, hopefully, Mr. Coker outlined the testing phase the spacecraft is now in. Big picture, the equipment panels were installed, the spacecraft was powered up for the first time, and now they are in test and checkout of its core systems. As he noted, they are starting with a phase of testing at ambient conditions, and he went through the 3 testing phases. First ambient testing, and then the quote-unquote shake-and-bake environmental testing. The thermal vacuum testing of the PPE in its in-space environment, and the launch loads and acoustic testing of the spacecraft in the launch environment. And then the final testing phase, when they, among other things, demonstrate that the working spacecraft can deploy its extendable hardware, like the solar arrays, after the shake and bake of its systems. Although, as Mr. Coker said, the bake part comes first. Some of that deployable hardware, like the ROSAs and other items like the electric propulsion system thrusters, might not need to be in place for that, but they would need to be installed for the launch loads and acoustic testing. I asked a few questions about the mission design and, of course, about the schedule, but NASA is in charge of those, so I'll keep trying to engage NASA's Gateway program to address those mysteries. How complicated of an operation is that? Is it, or how long is that expected to take?
Yeah, I would defer to NASA on specific timelines. Certainly is a lot of work, and we certainly would plan to take the time that is needed to make sure that gets done the right way. But as far as specific timelines, I would like to defer to NASA as far as the details there. We know what we need to do. We know what we need to support that activity, as well as our industry partners with HALO do. But as far as timelines and those type of details, we certainly would want to defer to NASA.
Okay, and then I guess I'll go ahead and ask the other timeline question here too. Just I think there was a government accounting office report mid-year talking about. I think they'd said that both of the elements were working towards. I think it was like a fall 2026 timeframe for delivery. Is that? Can you speak to that, or is that something that I need to ask NASA about?
Yeah, I would defer to NASA. I mean, we are meeting their schedule requirements as far as what their plans are on launch dates and things like that. I would certainly want to defer those to NASA, defer those questions to NASA.
Okay. The in terms of the spacecraft, does and I don't know that much about the 1300 bus. I mean, I know it's customizable and so on, but like, does the PPE have any like non-propulsive attitude control, like something like reaction wheels or magnetic torque bars, something like that?
Yeah, reaction wheels. Yes, we have reaction wheels.
Okay. At the end, Mr. Coker summed up where things stand right now with assembly of the power and propulsion element. Be interested in just kind of your, big picture view of where you are and how things are going right now. I know you talked about current status, but how are you feeling at this point in assembly and test of the spacecraft?
We're in the phase of this program that we know how to do very well, and that's assembling a Lanteris 1300 spacecraft to work and to be launched. The challenging part of this program was in the design phase, right? It was in figuring out how to integrate higher power solar arrays and the changes to the power system to enable that. The higher power electric thrusters and figuring out from an engineering perspective how to do that. All those questions are answered now, and we're in the phase of the program where we are building. We're in the phase of the program where, from a Lanteris perspective, we are enabled to do what we do best, and that's to get it built and get it tested and get it to our customers. So from a schedule performance perspective, we're in the phase where we know what to do, and it's just a question of making it happen. 2 years ago, when we were with a less mature design, I would have probably a bit more concern. But we're in the phase of the program now where we know what we need to do, and we have the team to go do it, and we're moving forward.
Okay, I guess just a quick follow up on that would be: is the project or the program in the phase now where the design is quote unquote frozen, for want of a better term? I mean, it sounds like that's what you're saying, which is that things have stabilized. There's not a lot of changes being pushed through the system, and it's more or less just building to the documentation and the requirements that you have.
That's right.
Okay.
And that's why I have the confidence that I do, is because the design has stabilized, and I've got a spacecraft in the factory that I can go look at that is in the phase where we can start meaningful testing. If the design were still churning, we would have had to stop, and we've reached putting the equipment panels onto the structure really constrains the changes you can make going forward, and we wouldn't have assembled them if there was major design uncertainty left. So that's why I'm confident where we are, because the design's frozen, and we've reached a point in the build where there's not a lot you can change going forward, and not impact the production. So that's why I think we're in a good spot. Those two reasons.
Thanks for watching. Like and subscribe if you find these videos informative and want to find out what's going on with Artemis every week. Big thanks, as always, to the members of this YouTube channel who are helping make it possible to keep doing this. I am posting additional content and updates if you're interested in joining. If you're willing to make a one-time donation to help support what I do, I would really appreciate it. I put a link to my Buy Me a Coffee page in the description. Thanks again, and I'll see you next time.